Good morning and good afternoon. Thank you for joining us and welcome to the Stantec Water webinar series. We're pleased to present Fred Johnson, our cybersecurity and risk expert. I am Tony Fink, your hostess for today. During this meeting, you will be in listen-only mode. We invite you to submit questions at any time during the presentation. If you are listening via computer or your mobile device, you can do so by selecting the Q&A icon in the top panel of your screen. Your questions will be addressed following the presentation. And with that, Fred, I'll pass it over to you to get us started.
Thank you, Tony. Good morning, good afternoon, everyone. My name is Frederick Johnson. I lead the cybersecurity practice here at Stantec. I'm based in beautiful Southern California, and I'm glad to be talking to you today about my favorite topic, which is cybersecurity, specifically in water systems. Today's topic is really around how do we thwart the attackers and how do we keep the water flowing. I've done quite a bit of work going out and visiting water utility executives across the country this year, and this topic has become much more prevalent, much more top of mind for many of them. So it's timely that we have this conversation today. A little background on me: I've been in cybersecurity for 25 years. I've been the chief security officer for a number of organizations, including Chief Information Security Officer for Esri, the company that makes ArcGIS, a product that I know many of us here use. I also did 15 years in software development, and I have a master's degree in IT with a specialization in security. And just a quick little fun fact, I'm a huge Chicago Cubs fan, so go Cubbies. Let's do a quick Stantec moment. I tend to think of cybersecurity as something that you can do much like you would take care of your teeth in the morning. You get up in the morning, you brush your teeth, you floss, hopefully, and then at the end of the day, you do the same thing. Good hygiene leads to less problems later on. It's not really that much different for cybersecurity. Regular updates, software updates can help with that, using strong, unique passwords that you don't share with your friends and colleagues, using antivirus products, using anti-malware products, data backups, multi-factor authentication. You don't have to know what all these things mean to understand the idea that together they are much stronger in helping you produce a more secure environment where business operations can occur. So from a Stantec perspective, that's our Stantec moment. We really want to practice good cyber hygiene, and hopefully that will have benefits for us down the line. So the first question that I get, particularly when I go out and do these presentations, is anyone really targeting utilities? Now, I think there's some general consensus out there that cybersecurity is an important thing to consider. I think there's even consensus around the idea that attacks are happening. But probably the number one question that I get, particularly from utilities and executives on those boards, is anyone really attacking them, targeting them specifically? And I think they're a little bit surprised to find out the answer to that. So we're gonna work through that. For years, IT systems, particularly in utilities, really were about monitoring operations, taking a look and seeing what's going on with the PLCs or the DCSs or the reservoirs or the tanks or what have you, the delivery, the pressures, the temperature. When the computer systems were primarily used for monitoring, there was some degree of belief that, hey, if the computer breaks or even if it's breached, all right, it's a little bit of an inconvenience. We got to send an engineer down. We need to actually manually verify the readings, make sure things are working appropriately. But that's changed. That's changed considerably because now we're using, and this is true in the last 15 years, now we're starting to use computers for controlling temperature, controlling pressure, flow, for controlling the individual valves and the individual tanks and the PLCs and all these different pieces of equipment. So with that new control that we have and that we want, have come opportunities for hackers to actually break in. So it's really this increased use of computers to control elements of these environments that has led to the change that we're seeing. So to answer my question, utilities are the most targeted industry of all industries out there. Energy, oil, gas, and utilities have the highest percentage of computers that have been impacted by ransomware just last year, 2024, the most recent survey. What this means is, and I'm showing it here on the chart on the far right, 62% of all computers, let me say that again, 62% of all computers used in energy, oil, gas, and utilities have been impacted by ransomware. More than half. It's a sobering number. And even worse, the attacks are still on the rise. We've seen a 140% surge in cyber attacks specifically against industrial operations. That has resulted in 150 new incidents that we did not think were going to happen. And then one more fact to really set this home. In a recent warning, the report says that more than 15,000 potential industrial site shutdowns may occur in 2027. So it's a very real problem. We're seeing clear evidence of it. We're seeing clear evidence of it in a number of areas. So I'm not going to get too deep into the technical weeds here, but I did want to give you some sense of what are the root causes of some of these disruptions. Exploited vulnerabilities is number one. What's an exploited vulnerability? Well, it's a piece of software that hasn't been patched in a long time, and hackers have figured that out. Once they figure that out, they start planning for their attack of that exploitable vulnerability. It could be in your operating system, Windows, for example. It could be in a piece of software that one of our manufacturers are using to control these sites. It could be a piece of software in an ERP package. There's a number of different places where we see these, but they really just all come down to there's a piece of software that has a vulnerability in it that a hacker figured out, and they're really going after hard. Now, a lot of people have sort of assumed, I think somewhat mistakenly, that hackers are going after what you see in the movies. They're going to pop the firewall, and they're going to open a socket, and they're going to do all these amazing technical wizardry kinds of things. That's actually a very tiny portion of what actually occurs. That falls into the brute force category. You can see it on the chart here. It's a very small portion of what's actually going on. It's actually much easier to break in than to actually have to try to break down a system. So we'll talk more about that as we go. So we know the attacks are real. We know they're really occurring. We've seen a little bit about where they're going to attack, how they're going to do it. But the next question I get, particularly from utility executives, is, well, they can't really hurt us, can they? I mean, after all, we have for years used computers and really haven't seen too much bad stuff going on. Well, the truth is, over $800 million US dollars in ransomware payments were made in 2024. 2024, just last year, almost $1 billion. I'd say that's hurting you. That's a lot of damage. Tied to that, we saw over 1,600 attacks per week, not per year, per week occurring in 2024. And then finally, 156 US cities were ransomwared in 2024. 156. Those are the ones that have reported. As you may know, the smaller ones may have not felt compelled to report and haven't, but we know at least 156 have published the fact that they were in fact ransomware. So we're seeing real damages, and we're seeing it a lot. Now, in 2024, May of last year, the APA put out an enforcement action that they wanted to make sure that that water utilities in particular are really thinking about how they're going to comply with the Safe Drinking Water Act. This was part of a government-wide effort led by the National Security Council and the Department of Homeland Security, Cybersecurity and Infrastructure Security Agency to reduce the vulnerabilities that we're seeing out there. They issued this alert mid-year, out of cycle, because they're so concerned about the threats specifically to the nation's water systems, because those threats have increased in frequency and severity. So it's not just they're being annoyed by hackers trying to get in. Real damage is there, and the government recognizes that it needs to step in and do something about that to help. So what's it really cost the average organization for a ransomware attack? Well, the average cost of remediating one ransomware attack, just one, in 2024 was over $3 million. $3 million for one. This does not include penalties down the road. This does not include fines. This does not include loss of confidence, reduced customer buy-in. This is just the initial cost of addressing the issue, investigating it, bringing a cyber forensic firm, involving attorneys to help draft your motions and your notices. This includes your PR firm having to put out the fires that go on tied to that and trying to position everything. $3 million per incident. Now, one little factoid to keep in mind here is that at $3 million for a ransomware attack, the FBI typically does not send an agent or assign an agent to come take a look at it. It isn't until we get to about $5 million in a ransomware attack that the FBI considers it a big enough attack to use their scarce resources to try to investigate. So there's a gap here between what you can expect from a ransomware attack and getting help from federal government in this case. So let's talk a little bit more about ransomware. Ransomware is still a major cause of loss and operational disruption. It's not the loss of water. Water keeps flowing. It's not wastewater not being treated. Nope, those things continue. But the people involved with managing those utilities are going to be spending all of their time and attention focused on how do we stop this ransomware event that has just happened. These are significant and they're not new. If you look back 5 years to 2020, we've been about the same amount of money in losses per year, almost $1 billion, and it is $1 billion on average for the last straight 5 years. Now in 2022, we did see a dip, and it was a significant dip, and many analysts attribute that related to COVID and maybe some reduced interest or even reduced hours available to attack some of these places that were actually shut down. But we saw a big spring back in 2023. 2024, we are at 813 million. Obviously, that's a nice. It looks good that it's going down, but it's very possible that we're going to see an increase this year. And most of the industry analysts believe that, in fact, we're going to exceed even the numbers we saw in 2024. Give you some recent examples that did make the headlines. In 2018, City of Atlanta suffered a widespread outage, and of course the fears that went from that in a major ransomware attack that occurred. This lasted more than a month before they got through it. Quite painful. In 2023, we saw Pennsylvania. We saw a particular facility there where a Pennsylvania water utility was hit by hackers that were in fact linked to Iran's Islamic Revolutionary Guard Corps. Kind of a surprise, particularly for those who've been in water a long time. We have a nation state now attacking us. Again, this was in 2023. This particular group, the Islamic Revolutionary Guard Corps, does have a history of making exaggerated and false claims about their hacking exploits, but they were successful in breaching a device at a remote water station, and the feds confirmed that. And then the last example I'll give you, this is in Tipton, Indiana. They saw a targeted attack, and this one was, again, a nation state. This was Russian hackers that actually attacked and caused a cyber breach at the Tipton West wastewater treatment plant. They noticed some irregular activities when they were doing their standard process monitoring. They immediately moved to manual control to bypass all of the computerization that they had in place. And in doing so, we're able to prevent anything adverse from happening in the wastewater treatment process, but certainly of great concern. And maybe perhaps of more concern, the fact that Russian hackers associated with the Russian government have been attributed by the FBI as being involved and being the ones that actually caused this. So there's some degree of belief that, who is it? This can't be anyone who's serious. This can't be anyone who's really trying to hurt us. It's probably just some kids out there playing. The evidence says otherwise. The evidence says there's actually great interest by other nation states in disabling permanently or temporarily some of our operations in water. So who's doing this? How are they doing it? And what are they really after? These are important questions we're going to take a quick look at. There's really, in my mind, 6 main categories of cyber threat actors. There's nation states, which we just talked about. There's cyber criminals who literally go to work every day. They show up at a job at 8 o'clock in the morning. They stand around the water cooler. Hey, how's your weekend? How are the kids? And then they go to work and they have projects to follow. And the projects include, okay, we're going to attack site number 3 today, and we're going to do surveillance on it. And we have goals that we have to meet, and if we meet those goals, those incentives that we're following turn into bonuses for us. And at the end of the day, they go home and do their do the family thing or the home life thing. It's an odd thought to understand that what we perceive as horrible attacks in certain countries are in fact not illegal, not horrible, and just considered a normal part of going to work. So we have cyber criminals who are looking for profit. We have hacktivists who may have ideological reasons that they're attacking. We have terrorist groups, which it's ideological violence that's involved. We have thrill seekers who want satisfaction. And for those of you who are asking, well, what about the kids in the basement and they got the cool computers and the big bowl of Skittles and all the Mountain Dew that they can drink, or Red Bull if you prefer? Where do they fit? Well, they're the thrill seekers, and they represent a tiny portion of who's actually attacking us. The FBI has learned over the years that they're probably less than 2% of all the attacks that we see. The final one on here, though, is interesting. The insider threat one has always been there. This is often disgruntled worker, very unhappy with where they're working. Unfortunately, we often see this in IT. The individual decided they don't like working there anymore. They want to go somewhere else. They want to get they want to get recognition for what they do. And they've decided to cause some damage or steal some things on their way out. The insider threat is usually based on discontent, but it's very, very effective because generally the insiders have access. They're authorized to be on those systems. They know where everything is. So unlike all the other groups, they're not spending all their time trying to figure out and surveil a network. They know where the stuff is. So those attacks can be devastating. Common attacks, I'm not going to go through all of these, but there's a couple that really stand out. And let me just click on this so you can see these combined attacks. So phishing plus a malware, that's a very powerful attack. If I send an email to someone, it says, click here to get your gift card because you've been such a great employee, and the person gets that email and thinks, oh, this looks legit, and they click it, they are in fact probably at that point allowing the attacker to download malware to their machine. We'll talk a little bit more about how that actually then plays out. And then the ransomware attack plus a distributed denial of service attack is also devastating. What we have seen, particularly in the last 2 years, is ransomware attacks that, again, it gets everybody's attention. Everyone's trying to figure out how to get their equipment back under their control. They're working with the attackers to decide if they're going to pay the ransom or not pay the ransom. And then suddenly they get attacked where all of their servers are overwhelmed with requests from the outside. And in doing so, it shuts down those firewalls, those routers, those FTP servers, those email servers, and makes it almost impossible for them to actually conduct business. And the only thing they can do in those situations is contact their internet service provider, often very large company like Verizon or AT&T, and have them fix the problem through some means that they can take. So those can be very difficult. But again, these combined attacks are very powerful. So quickly, I want to go through a ransomware attack. This is a question I get a lot from executives in water. What exactly is occurring? Well, it starts with delivery, and I've described a little bit of what that's like. You get an email, you have a link, or you get an email with a document. You open the document thinking it's something good. It, in fact, has a piece of malware in it. That malware then embeds onto your laptop, onto your computer, what have you. From there, that piece of software on that laptop then talks to a server outside of your environment run by the hackers. We call this command and control. Goes right through your own firewall, talks to that server, and starts to bring more files from the outside onto that machine. With those files, it can then establish complete control over that box. From there, it starts to develop credentialed access. It starts to look and see what other accounts are on that network, and it starts to pull those credentials down anywhere it possibly can. If that machine is able to access other machines on the network, it will often surveil those machines and try to find the passwords that are stored by Windows in a encrypted fashion, lift those off. Once it has that, then they start to explore the network. They typically, and I'll talk about this a little bit more in a minute, they typically aren't interested in an immediate attack. It may seem counterintuitive, but most attackers are taking a long view when they perform an attack. They get in, they establish that control, but they're trying to do that in a very stealthy way. They don't want anyone to notice. And the quickest way to get noticed is if there's suddenly a lot of activity on a machine that was unexpected or unaccounted for. So instead, what these attackers will do is they'll do that initial delivery, get that malware onto a machine, and then they'll let it sit there for a few weeks or months in many cases until they are ready and confident that they haven't been noticed yet, and they will start to surveil and explore the network. From that exploration extortion, they start to build out an inventory of where are all the devices that they have, what kind of software do they have inside, where are the file servers, can they get to some of the files that are in those file servers? If it's a SharePoint environment, do they have access? Where do they need to get more access? Once they have that, that's really the point at which they fully own the network and have complete control over it. From there, then they can perform the extortion piece, which most of us associate with a ransomware attack. This is actually the part where suddenly a box, a laptop, reboots itself and comes up and you can't get in, and it says your box is now owned by such and so party. If you want it back, please send 3 Bitcoin to the following Bitcoin address. Until you do so, we will double this amount every 48 hours until you agree. So that's really the point at which criminals are now beginning to steal or encrypt files. They're demanding payment for access to those files. Now, one comment about this that I do get asked a lot is, do the hackers always give you back access after you pay? The answer is no. 5 years ago, the answer was yes, but now that's not true. In fact, the FBI now says about 33% of the time you will get access after making payment. In other words, 2/3 of the time you don't get access. So that makes this situation even worse when you realize you're not going to get back anything and you probably already paid the money. So one key point, because I don't want to doom and gloom the entire presentation for you, these attacks could have been detected and stopped right at that delivery phase. There are a number of things that could have been done, and they're not all magical technical solutions. A lot of them are really related to training, they're related to process, and if those things had been done, the attack could have been effectively stopped at that point, would not have proceeded. So a lot of doom and gloom. Well, I want to tell you what can we do about it. So there's really 3 main areas that we can reduce risk. We can prepare in our ransomware security operations. We can do user education. We can do awareness. We can certainly test them. I'm sure many of you have seen those emails that come in that look like they're probably not legit, and you're not supposed to click on anything. You're supposed to report them as junk. And when you do report them as junk, you never hear about it. But if you open them, all of a sudden you get an email from the IT group saying, you got caught by our ransomware testing. Now you have to do that 1-hour class again and learn how to catch it. That's actually very effective. And it's super effective if it's done on the regular, not once a year, but done regularly. It's one of the more effective ways to get people to stop clicking on or opening things that they shouldn't. Early cybersecurity design specifications are also another major way in which you can reduce risk. So there are weaknesses in the technology environments that we build, that many organizations build. But really the best place to find those and address those is when you're early in your design phase, not after the thing has been built. We always refer to that as sprinkling a little bit of security on the end of at the end of the cycle, and it does almost no good. We need to build that security in right from the beginning. So to the extent that you have projects where you're early enough in that design phase, this is really the place to do some threat modeling, testing some what-if scenarios, figuring out the hacking scenarios that could occur in those systems that you're designing, and having someone from the cybersecurity side provide you with some input on how to address it. Third area is really around, so what do we do if we have an existing cybersecurity infrastructure? And I get this one a lot, particularly from larger utilities. They're not designing from the ground up. They've already got a mature operation and infrastructure in place. They want to know, is there anything I can do? Well, the answer is yes. You can still effectively make major improvements, even to things that are operationally underway. And these don't require major capital investments to occur. But you do need to start these conversations and try to understand where are the risks and what can I do about them. So what's the answer? Well, the first answer I would offer is there's really one great way to address risk in those 3 areas. Cybersecurity assessments are really fundamental to each of these scenarios. They really provide enough information that you can understand the nature of the risk that you have, or risks. You can understand which ones are more severe than others. You can understand which ones are more difficult to fix, right? That's an important element of this. You can try to understand a little bit around the cost and the solutioning that would go with that. But all of this is important to understanding what can be done about it. So what is a cybersecurity assessment? Well, a cybersecurity assessment takes a look at your current state, your current cybersecurity posture, and it compares it to a desired future state. If you don't know what that future state is, it's okay. Cybersecurity people can help. We typically base this on one of the major frameworks, cybersecurity frameworks that are out there. We'll talk about those in a minute. But the idea here is that we're going to perform this assessment to understand where we are and the gap between where we want to be, and then really think about, what does that mean for us and how do we achieve it? Some of those frameworks include NIST CSF, Cybersecurity Framework version 2.0, the AWIA of 2018, which is now the Safe Drinking Water Act of 2023, NIST Special Publication 882, Revision 3, and some other standards that a number of organizations have adopted. I would suggest respectfully that AWA, which is now the Safe Drinking Water Act, and NIST 882, these are the best frameworks, particularly for the OT environments, the ICS environments, the SCADE environments, if you will, because these are specific to those kinds of concerns. There's nothing magical about these, but it really just focuses, it brings the scope down specific to issues that we find in OT environments. The other ones are fantastic for the front office operations, for the ERPs, the HR, the finance systems, the accounting, all of those areas that are typically affected by ransomware. So it is some combination of these that are probably going to be most effective. So I do get a question about, so what does the framework assessment actually cover? It covers these areas. It covers asset identification and classification. For those of you who are engineers, you have to know what you have in an environment before you can think about how you're going to protect it or use it. It's no different in cybersecurity. We cannot properly analyze an environment to understand where all the risks are unless we know everything that's in that environment. And typically, the breaches that we've seen in the last 10 years happened because they didn't know everything that was in the environment. They didn't know there was a jump box sitting somewhere that they had never seen before. They didn't know there was an IIS server, web server running that someone had put in place 6 or 7 years ago, and then they left the organization, but the server was still running, and attackers found it. So the asset identification classification is absolutely critical. You have to have a complete and current understanding of what's in the environment. Security control strategy, very important. What are we going to actually use as our framework? We need to think about our ongoing risk mitigation. How do we want to address that? A vulnerability assessment, really key. We want to understand in software and hardware where we're vulnerable, what needs to be done to make sure that we aren't vulnerable today, and what do we need to do on an ongoing basis to make sure that that doesn't happen. Compliance assessment, and I'm going to stop and pause here just a minute because this is one of those moments I want to make sure it's really clear. I get this question a lot from executives, particularly in water, who say to me, we think we have it covered. We're supposed to do an assessment, a compliance assessment. We're good. I'm here to tell you that compliance does not equal security. Let me say that again. Compliance does not equal security. You can achieve great compliance. You can do everything on the list, and you will not in any way be more secure than you were before, because compliance, the purpose of compliance is to match a checklist that someone decided these are the minimal things you should be doing. They do not in any way translate from a practical perspective into you suddenly being secure everywhere all the time. We have a concept called the defender's dilemma that matters here. As a defender, it's my job to defend everything we have all the time, 24 hours a day, 7 days a week, in any way we might be attacked. That's a pretty tough and a tall order. The attacker only has to do one thing. They have to get in one place, one time, one way. So the defender's dilemma is it's almost impossible for us to defend everywhere all the time from any kind of attack. So we have to figure out, all right, what are the main things we need to do? And that's where compliance comes in. Compliance says, well, we know we can't do everything. Let's say there's 1,000 things we could do. We can't do 1,000. We can't afford it. We don't have time. We don't have interest. Let's do 100. Well, if your compliance assessment goes and checks to see if you've done those 100 things, guess what? You've missed 900 other ways in which attackers can get in. So I'm going to get off the soapbox for just a minute, but it's important to understand that while you do need to be thinking about compliance and making sure that you're compliant, particularly with, give an example, the Safe Drinking Water Act, it has two aspects to it. You do need to do those things in order for the EPA to be happy with you. That does not mean once you're done with that you're now secure. Documentation and reporting, obviously very important. We want to push information up the chain and out to our boards, to our commissioners around what does our cybersecurity story look like. Impact analysis helps us understand in the future if there's an event, what would happen. the incident response plan, which many organizations don't have, surprisingly. They've never written down what are the steps we're going to follow in case of a breach. And I'm going to harp on this in just a minute a little bit more. An absolutely critical element tied to that is risk communication. If we have a breach, who do we tell? How do we tell? How do we tell the public? How do we tell our partners? How do we tell our vendors? Right? And that goes both ways. What if our vendor has a breach? Do they communicate with us, and how do we manage that? Risk scoring, I would argue, is an important element. It helps you understand a degree of severity in the things that we find. A recovery plan, of course, would be great. How do we recover from a ransomware event? Do you have the capability of doing that? Have you ever tested it? And then, of course, security training and awareness, absolutely critical elements. So let's talk a little bit again about NIST CSF version 2.0. These are voluntary guidelines the U.S. government has created. They're voluntary, so let me make sure that's clear. This is not something you have to do. This is something that they put together and said, we think this will be helpful advice. Basically, it's going to help you assess and improve your ability to prevent, detect, and respond to cybersecurity risks, right? Very useful, and a nice little cottage industry, if you will, has grown up around it with lots of different spreadsheets and tools and techniques and white papers and things to help you really understand how do we get there. And again, this is primarily of value in preventing ransomware and some of those other kinds of things. For me, it's not necessarily the first instrument I would use on the SCADA side. I think there's other instruments that are better for that. The AWIA, the America's Water Infrastructure Act of 2018, this has really reshaped cybersecurity and resilience requirements, particularly for community water systems. So they have to assess their cybersecurity vulnerabilities in a comprehensive way. There's a couple of instruments that they use. They use an emergency response plan. They use a risk and resilience assessment. These two instruments are becoming mandatory, and the utilities that are affected by this have probably already been notified. Your clients, or if you're in the water utility industry, already know this, but these are elements that you have to fill out, hopefully clearly, cleanly, accurately, and provide that information back to the EPA. It is the kind of information that, should you experience a breach, and that you have already turned one of these in, that they will absolutely compare what you said you do in those risk and resilience assessments and your emergency response plan to the actual steps you took and to what they find in your environment when they perform the investigation. So it's critical that these things are done well and done thoroughly. And then the last piece is NIST 882. Again, this one I see as being very valuable, particularly for the ICS OT environments, the SCADA environments. It's comprehensive guidelines around how to secure the ICS and other critical infrastructure components against cyber threats. Now, again, doing all the things in here doesn't mean that you're immune or impervious to attack. Not at all. But it certainly improves the chance that you're going to survive it, or that the impact of an attack will be lessened should you have carried out a lot of these things. One more that I think is very useful. We've seen the emergence of a new cybersecurity industrial standard from ISA and IEC together. This is 62443. This puts together a set of common terms, concepts, and models, particularly for control systems around cybersecurity. It creates a set of zones, if you will, that help you understand how you might think about dividing up equipment that's in an ICS environment, from a much less security zone all the way up to a very secure security zone, and how you might think about where to put your equipment, where to put your assets, and how to protect those different zones. It establishes a common set of requirements and a cybersecurity lifecycle, which is very useful, and it helps define a risk assessment process so that you can, on an ongoing basis, have some idea of what kind of risk you're carrying inside those critical environments. We have seen additional support from the industry. The ISA has a Security Compliance Institute. The goal here was really to create some certifications that, in particular, OT environments might take advantage of around some specific ideas. Now, I would suggest humbly that this is probably for the larger municipalities, the larger organizations that use water and wastewater treatment, but certainly very useful. Component security certification, and Internet of Things component security assurance certification, and a system security assurance certification. If you'd like more information, these are available to you. You can always, of course, reach out to me and I can talk to you a little bit more about it. But this is another set of comprehensive resources that can help you really build out some security resilience in these environments. It's interesting. I do get a lot of questions around. So I'm in a utility. I've already got an environment. I'm in operations and maintenance right now. I'm not building a new environment. We're not greenfield here. What can I do? Well, there's some very specific things you can do. You can do threat assessments against those environments, and of course, we can make sure that you understand what assets you have. The threat assessments are useful because they really can help you understand where am I likely to be attacked? Where are my exposures? A rudimentary example would be, we go on site, we take a look, and we notice that one of your pump stations, the outside door is propped open with a cinder block from time to time, and we see well-meaning engineers stepping out to have a cigarette for 15 minutes, and sometimes they'll, in the midst of having that cigarette, remember they left something in the car, and they'll leave the door open, but they'll go to their car, they'll get on the phone with their loved ones, it's their kid at school's teacher, they're having an argument for 20 minutes, they come back. Meanwhile, that door was open for 30 minutes with no supervision, with no video cameras over it. And certainly someone could have come in and done any number of things. They could have come in and changed settings. They could have shut things off. They could have unplugged stuff. They could have installed malware on machines so they could surveil. So there's quite a bit that you can do even on an existing operation to understand where are my threats. But as I mentioned on a previous slide, it's ideal particularly if you are going to be improving your existing site, or perhaps you're involved with a pure water project, to do as much as you can, as early as you can around cybersecurity in that planning life cycle. Get in there and take a look at the SCADA plans, take a look at the emergency response that would go in there. What does acceptable emergency response look like? How long can you be out? Right? It's a good question that a lot of utilities are starting to ask. Most of them, I think, know the answer. They think, well, I'm going to be out until someone calls and screams at me. Not a great answer. A better answer is we think we can go 8 hours with an operational disruption, no more. That's our number. So we need to make sure that whatever response planning we do can bring us back to full operations in 8 hours. And then as we build and design and test, we start to understand, can we really achieve that? Do we have the right infrastructure in place? Do we have the right processes in place, procedures to make that happen? And are people trained on making that happen? If we do, wonderful. In the design phase, obviously, there's a lot we can do there in terms of putting in the right monitoring systems, putting in the right protection capabilities to prevent attackers from getting in, from preventing attackers from walking right in the door just because the door was propped open with a cinder block, and to really understand that. This is where we can use biometrics. This is where we can use surveillance. This is where we can do quite a bit to actually really harden those environments. In the construction phase, obviously, we want to make sure that what's going in construction isn't going to be defeated because someone decided, hey, it's too hard to get a camera here, or hey, we don't want to put a badge system right over here. Those are issues that have a cybersecurity impact to you from a posture perspective. You want to make sure you cover it. And then in terms of ongoing support, there is quite a bit that you can do there. The ongoing training for your personnel, again, is critical. Help them avoid clicking on the wrong thing and getting ransomware. And then, of course, making sure that your vendors are equally secure as well. You'd want to take a look at what do they have in terms of security protections. Has any third party ever verified their security? And most of the larger vendors that we work with, particularly around SCADA, do have that. We want to make sure that you know what it is that they should be following. So one really key thought that I want to make sure that everyone's clear on, particularly as we finish up here before we take some questions, is this idea that the time to plan a proper response to a major security event is not during the event itself. This may seem obvious to you, but I can tell you from having worked hundreds of breaches in the last 15 years that almost 100% of the time, they're trying to figure out as they go, the team that's responsible. And they don't even know who to call. They don't know, should I call the president or the CEO right away? Should I call the IT manager? Should I call our lawyer? Should I call the person who's in charge of PR? Even the people who are working the problem don't know who to call and what to do next. Now, can that be fixed? Absolutely. This is where incident response planning really helps. You create a policy that outlines this is how we're going to do it. We expect to have an incident commander role defined, and it has to be someone at a certain level in the organization. We expect that the IT people will not communicate to the outside. They won't do that. They'll run that through the incident commander. It would lay out instructions that the incident commander is going to work directly with the Office of the General Counsel or with external law firms or whoever your internal lawyer is to make sure that you're best protecting the organization in the event of a breach. It would make sure the incident commander knows what is their role in communicating to the outside. Does that go through the CEO, the board, the commissioners? Does that go through somebody else? Does that go through the PR firm directly? Right? All of those critical pieces that are part of working through this kind of issue have been predefined. Everybody's looked at it and agreed, yes, these are the right steps that we're going to take. And when you then go out and have a breach, yes, you're going to be worried and nervous and maybe even a little scared, and there's going to be a lot of anxiety, but you're not anxious about what's the process to be followed to address it. That part you know, and if you've been smart, you've tested it a few times to make sure on paper that everybody knows their role. These are good tests, by the way, to take on, to understand where do we make mistakes. And I'll give you a concrete example of why this is so important. I had a client a few years ago that was a research facility attached to a major university. The university was a state-sponsored school. We came in and did a business continuity test for them on a ransomware, a simple ransomware attack. We took them through the steps that would occur in that attack. We started with one of your employees just notified the help desk that there's a weird red screen on their machine after rebooted. It says something about Bitcoin and recovering files, and they don't know what to do. And so we had on the call, we had the CEO, we had the IT leader, we had the general counsel, we had the chief operating officer, we had members of the IT team as well to see who's going to do what. And we sat in and wrote down every step that they were going to do and graded it, if you will. You know, here's where you could have done something differently. Here's where you could have done something better. But what they learned during this exercise was that it would take them approximately 6 weeks to make the Bitcoin payment demanded by the ransomware attacker. That's right. Let me say that again, 6 full weeks. The reason for that was, well, there's several actually. They learned that their bank would not issue a check for $3 million, so that they were in fact limited to $1 million. And in fact, their bank, even if they could, would still require the state controller to approve it, which was a manual process that was done entirely on paper. So they would have to draft the request on the state form, put it in an envelope, get it over to the state board, and then the state controllers would look at that in and amongst all the other demands that they had and process that, which was typically 2 to 3 weeks to get done. If they agreed, they would send a check back to this research group, who then would have to deposit that money into their account. Now, again, they already knew that their bank would not allow them to write a check that big, so they'd have to open up a new bank account, which would take 7 to 10 more days. They're sitting on a $3 million check. They got to wait 10 more days now to deposit the check, only to find out that that bank would not allow them to purchase Bitcoin from any of the Bitcoin providers out there. So they had to get a brand new bank account with a brand new bank they've never done business with. And then once they got that done, they'd have to deposit the check, wait for it to clear, which would be another 10 days because it's a brand new bank that no one's ever seen before, seen this particular account. And then they would open up their Bitcoin exchange account, only to find out that you have to wait 48 hours in order to actually make a payment greater than $10,000. So all of these steps, right? Every one of these steps serve to delay them being able to legitimately pay the ransomware attack. Now, they didn't want to pay, but they knew right away that they didn't have backups they could restore from. They knew right away these were critical systems. So in and amongst this 3-hour session that we did together, they learned the exposure that they really had. That exposure being that they would probably have to wait 6 to 7 weeks to get the money to them. And then again, going back to the FBI statistic, 33% of the time, companies get their assets back after paying the ransomware. So there was still a decent chance that they weren't going to get those systems back. So these sorts of exercises are critical. You don't want to find these things out as you work through a real life situation. And I can't stress enough how important that is. It is amazing to me that even today, we still don't see utilities, and not to pick on utilities because I think this is pervasive across most industries. We don't see them taking this kind of preparation seriously. There's a legal element to this as well. And typically, in most jurisdictions, there's a notice requirement from the point that you first know that you've actually experienced a breach. You're not suspecting it, you know it's a breach. Typically, you have a limited and predefined amount of time by law to notify certain parties. Sometimes those are constituents in the state. Sometimes those are specific bodies, governing bodies in the state. Those notice periods begin that moment, typically, that you have determined you have an attack. Well, if it's going to take you 6 weeks to work that problem, you're probably going to miss some of those windows, right? And those come with real penalties as well. So there's a lot writing here, not just the operational disruption, not just the cost of losing, the money that you're going to spend on Bitcoin, not just the long-term penalties. There's just so much reason here to really get good at this and to plan for it and to test it as much as you possibly can before you get there. So I'm going to conclude here before we take questions around this idea that cybersecurity, you really should be thinking about this as just another aspect of a good safety culture, in the same way that we try to build a good safety culture in everything we do when we're designing and building and operating water utility systems. Our goal has to always be the safety of the people, the assets, the resources, and the community at large. So I'm going to stop there. I'm happy to take questions. I'm going to check and see what we've got here. If you have questions, please, by all means, go ahead and put them in the chat.
Yeah, thanks, Fred. Great topic. We do have a couple good questions here to start, but like Fred said, you could drop more in the Q&A panel located at the top of your screen. So here we go. First question in. What makes water utilities such an attractive target compared to other industries?
Yeah, it's a great question. So water utilities sit at the intersection of critical infrastructure and public health, right? They provide an essential service, often with limited downtime tolerance. That makes them high-value targets for both nation-state actors and criminal groups, right? Criminal groups know you're going to pay. You have to pay. You have to keep these systems up. Nation-states really understand that this gives them some geopolitical leverage if they can actually affect our ability to deliver water, clean water, and to treat wastewater. We also tend to see utilities have operating aging, I'll be kind, aging SCADA and ICS systems that really weren't designed with cybersecurity in mind, which the attackers tend to exploit. I'll add one more element to that, and that is particularly with the smaller utilities. So I'm talking the small utilities here now. We see attackers learning their craft on the smaller utilities because of their belief that these smaller utilities probably didn't have the money, probably didn't have the expertise, probably didn't have the infrastructure to really detect the attack. And so there's some belief in the hacker community, I think, that you can practice what you're doing, your hacking techniques, without likely getting caught, with less likelihood, certainly, of getting caught than if you tried it against a major municipality. So I think that those combined make water utilities in particular a very attractive target. Great question.
All right, you mentioned this topic earlier, but can you reshare what the role of regulatory requirements are for legislation, for instance, the American Water Infrastructure Act of 2018?
Yep, great question. So just to reiterate, the Water Act of 2018 really does require water systems to conduct risk and resilience assessments, which have as a major component cybersecurity. That's really required utilities, particularly those that are affected by this, to adopt formal frameworks for cybersecurity, such as NIST CSF 2.0 and NIST Special Publication 882. While compliance is the driver, right? That is the driver from the EPA's perspective. The real benefit here is that you have a repeatable process for identifying your vulnerabilities, developing your response plans, and improving resilience over time. So the EPA is, in my mind, doing a very good thing in saying, look, you got to be compliant, but they're giving you something legitimate to work with that's going to help you be more secure in the long run if it's followed. Good question.
All right, so how about this one? For utilities, what is the range of cybersecurity budget as a percentage of overall budget?
Yeah, that's a great question. I get this one a lot. It's interesting. Uh, Even in non-utilities, this question comes up all the time. How much should the security budget be? Typically, it's in my 25 years of doing IT cybersecurity, it's typically tied to the IT budget as a percentage. It can range anywhere from 7 to 14%. That's common. It doesn't mean it's right, doesn't mean
Mhm.
it's optimal, but it is certainly common. On the utility side, I think it's probably at the lower end of that because I don't see a lot of evidence that, to be blunt, I don't see cybersecurity leaders inside SCADA environments. Typically, that's someone who's sharing duties with the business side, the IT side, and the SCADA side. I don't typically see a dedicated cybersecurity engineer on the SCADA side. So I would be not surprised at all if it wasn't closer to 5 to 7%. Now, what is a good number is a better question. What should you be spending? And I don't know that this should be based on a percentage of budget. I think this should be based on the assessment you do, the risks that you identify, and the remediation roadmap you decide you want to build. If you decide we've got a lot of risk and it's going to take us $1 million to fix it, but we only have $100,000 to do so, then you've got to stretch that out over a 10-year plan. You're going to have to address the more important issues up front and perhaps the less impactful issues as you go. But simply deciding we're going to take 3% of IT doesn't really tie you to the risks. That just ties you to a budgetary number. So in my mind, the percentage approach, although it is commonly in use, isn't necessarily optimal. Good question.
Yeah, good response. People, I think, need to remember to think in the should world as opposed to what. Um, all right. So next one, from your experience, what are the key elements of a good recovery plan?
Yeah, great question. So recovery plans have to include exactly what we're going to do in case we don't have access to the box at all. What if the box breaks, right? I've been focused on this presentation a lot around ransomware, which has a temporary or permanent disruption aspect to it. But the truth is sometimes machines just break. So what do we do when a machine breaks? What do we do when the historian machine breaks inside the SCADA environment? Well, you really should have a plan for how you're going to replace it. My presumption is you would have backups for all the data that's on there, and preferably 24 hours old, if not less old than that, right? So that we're only going to lose a day's worth of transactions or logging or capability. I would presume that the applications you have software ready to go that has all the updates so it can be reinstalled on that machine. There's a number of different ways that you can perform recovery, uh, but really the key one there is, does your plan meet your business need? And I mentioned earlier, if that's 8 hours, if you can only be down 8 hours, then your recovery plan has to get you back operating in 8 hours. So can you rebuild a machine, put a new operating system on it, install all the applications, put all the data back, and then swap it in line in an 8 hour period successfully every time, then you know you can meet that objective. But if you can't, then you need to figure out, well, first, what does it really look like? Is it 12 hours? Is it 16 hours? And communicate that up, and then work on ways to reduce that number so that it works within the operational parameters you've defined.
All right, we got a couple good ones that just came in. Can you talk about the Purdue model for OT security, how much adoption it has had in the water industry, and how much of a hurdle it is to adopt it?
Yeah, that's a great question. Let me stop here. So Purdue model is interesting. It's in version 2 now. Purdue model is a very useful model for specifically for understanding how to place assets in a way that they're going to be well protected. And it's tied to this idea of security zones, if you will. These security zones can also be very, very useful in understanding our most critical things that we need to protect. Perhaps the PLCs and DCSs cannot be exposed at all. They really should only talk to some assets within that SCADA environment. It helps create this concept that we call zero trust, where each environment inside SCADA only talks to the next protected environment. You can't get all the way into it without going through a whole bunch of doors, if you will. So the Purdue model has gotten a lot of I'd say a lot of adoption by the organizations that have decided to protect their SCADA environments. It's not the only way one might do things, but unfortunately, what we've seen is many utilities have simply a flat network inside their SCADA environments. They have one firewall and everything is behind that. That makes it very easy if you get through that one firewall to create all kinds of nuisances and malfeasance. We don't want that. We want you get through that first firewall, you shouldn't have access to everything. You should have only access to the first layer of things that you need, and work your way through a number of doors until you get to the really important stuff. So I think we are seeing adoption of it. I certainly talk about it with all of the audiences that I can around. Let's get away from that convenient, inexpensive, flat network that you've got and put in a properly protected network so that if someone does break through that SCADA firewall, they didn't suddenly get to everything, right? They're not suddenly now playing with valves and pumps and reservoirs and all of these sorts of critical infrastructure components in the SCADA environment.
All right, two-parter for you. From a design perspective, which component of network design are most vulnerable and easily accessible by the remote cyber attackers? And what protection should be kept in mind while designing the network architecture?
Yeah, it's a great question. So the Purdue model can really help with that. One of the things that we frequently see, even at the design phase, is an expectation that there's going to be a wireless gateway inside the SCADA environment. This is typically for one of two reasons. It's either because the staff that manage these environments are fully remote and they want to be able to get in quickly on a mobile app to check settings, to see what's going on. Or the other scenario that we unfortunately see a lot is someone in very senior leadership or on a commission or a board wants to just peek in every once in a while. And they want the convenience of being able to do that on their phone. That's one of the quickest ways to create exposure in your network, even before you put any other controls in place. So the Purdue model, I think, is absolutely critical in adopting and designing a network infrastructure around that. Now, which component is most insecure or could be attacked and cause the most damage? Well, there's a lot, right? The Active Directory, presumably the server that's in there that has all the credentials, that's rather important to keep that protected. Anything that's acting as a jump box that's allowing people to come in, very important to protect. But I would argue that some of the other pieces, like the engineering workstation, the HMI, these are pieces that directly interface with equipment that can shut down or alter operation, right? So I think from a design perspective, making sure that you understand how could someone break in, what would they need in terms of credentials and access, and do the firewalls allow it? Are those things enforced or going to be enforceable? And what other capabilities might you put in place, perhaps like NAC, network access management, ways of defeating attacks that might occur in all the ways in which your threat modeling would have revealed? I think all of those are critical. I don't know. I like the premise of the question. Is there one or two specific spots that you should do this? Yeah, there are. But again, going back to the defender's dilemma, we have to protect everything all the time from any kind of attack. So any device that's vulnerable is the weakest link in that chain and allows the attack.
All right, I hope people can stick with us. We've got two more questions I don't want to miss. So this first one, can you talk about what goes into the decision-making process to either pay or not pay the ransomware request, and who ultimately makes the decision, especially with such a low chance that the payment will actually result in services restored?
Yep. Great question. So if you have a breach and you contact the FBI, which you're supposed to do in the event of a breach, and you tell them we are being breached, and the demand is for $3 million, and hey FBI, what should we do? The FBI is going to tell you unequivocally that you may not pay that payment legally. It is in fact illegal to make a ransomware payment. This isn't necessarily common knowledge, but I've worked a number of these breaches, and every time I'm there, the FBI says our official position is you may not legally make that payment. They also tell me that they've never prosecuted any company for making the payment. So there's a legal argument to be made here, and my suggestion is that's a conversation that you have to have with your general counsel, with your legal advisors, whoever has that background, and perhaps more importantly, the legal standing to provide you with that advice. Who decides? Well, it's likely to be a combination of your legal advisor who says, here's the law. It's probably going to be your chief operating officer saying, oh, how quickly do I have to get this site back up? And to some degree, certainly it's going to be your board, your CEO, who are being hopefully informed of all this and trying to decide, do we really need to do this or can we wait it out? Now, as to the question of likelihood that it's going to get you back where you need to be, that's a gamble. And unfortunately, it's like any other gamble you take in business. You could pay $3 million and get nothing from it. You could pay $3 million and get your stuff back, but they delay you 3 or 4 days while they wait for the money to clear and clear it out of Bitcoin. So it is absolutely a gamble. There's absolutely no guarantee that it's going to result in you getting your systems back. And in fact, statistically, there's a greater likelihood that you won't. A better answer is start thinking about how you're going to improve those systems that you rely on so that you can quickly and easily restore them from backup, restore them, rebuild them, get them in place quickly. Then you don't have to have these awful conversations that so many companies have had to go through recently.
All right, last one to wrap us up today. Considering the high likelihood of AI-driven attacks in the next 5 years, wouldn't it be essential to start revising our frameworks and standards now? In your view, what concrete steps should be prioritized to ensure AI-specific threat modeling, risk assessment, and incident response planning are properly integrated into current security strategies?
It's a great question. The person asking the question knows our number one issue in cybersecurity right now. Assuming that what we're talking about here is how AI is being used to perform attacks, how it's being used to surveil networks. Yeah, this is our number one issue right now. We know that cybersecurity analysis being conducted by AI is occurring 1 billion times faster than humans can do it, and about 1 million times faster than current machines can do it without the use of AI. We can do scans of ports, we can do scans of systems. We have great tools that allow us to, on an individual basis, find problems, but AI allows you to do this in bulk across hundreds of thousands, if not millions, of individual computers. So do we need to do something about that? 100% yes. Are we working on this? Yeah, we are as an industry, and particularly on academia. This is probably the number one issue that's got all of us worried. Because we know that at the moment, there isn't a simple answer to this. Now, the attack surface, right? That's the vulnerabilities in your infrastructure. That's the software that hasn't been patched. That's the machines that are 12 years old. That's the Windows 2002 servers you're still running because you haven't upgraded. We know on the attack surface, that isn't what's changing. What's changing is the speed and the predictability, the quality of those predictions that is dramatically improving. So we're getting a much more effective set of attackers, and they're doing it much more quickly. So the industry absolutely knows that there are a number of things that we need to do. A lot of those really relate to technologies that need to be put in place to detect and repel large-scale attacks that are trying to probe our networks. And of course, all the major security vendors out there are working on that. But there is some degree of work that needs to be done on the cybersecurity frameworks that says, this is how you're going to think about that. And these are the kinds of controls specifically geared to repel AI types of cyber attacks. We're not there, and we need to get there much faster than I think we're proceeding.
All right, and with that, we are going to wrap it up today. Thanks for all of your participation, and thanks again, Fred. You will receive an email shortly with a link to download your participation certificate. We will also be posting this presentation on stantec.com if you would like to listen again or share with a colleague. Our next presentation will be on Wednesday, September 10th, where our panel will be talking about asset management transformations and the next evolution of operational strategies. We hope you can join us again soon. Thanks, everyone.